Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. I'm sorry if the music's weirding out Cube at the main. I do definitely apologize for that. And also, sorry, I am still kind of technically putting on my shirt. So that is the deal. Gathros coating with ethanol. Cube at the main. Thank you guys so much for coming in. Really appreciate it. As you guys can see, these terminals were literally just working on the tree images and stuff like that we were doing yesterday. So if you remember from, I don't know, like, what was it, yesterday? Wow, it seems like so long ago, but yesterday it actually was. Let me go ahead and seed into projects, Simuleos, Fractal, and let's go into tree, I believe, tree images. And let me just do GIMP, not GIMP, I'm sorry, Mirage, and I guess it's out.gif. So here was the GIF of the fractal Christmas tree that we generated yesterday. I'm genuinely happy with this. Sure, it's not the best fractal Christmas tree ever, but it's not bad, you know, for a fractal Christmas tree. I'm okay with it. The shape is correct. The colors may be a bit incorrect, but it's okay. It was a good attempt. This is what we were working on yesterday. Now, I want to start talking about what we were doing last week with the GPU stream and all this kind of stuff. Talk about the schedule, where we're going, what we're doing, all this kind of stuff. So let's just jump into it. That was the catchphrase of the ever popular PewDiePie. Oh, no, I'm sorry. Ever popular Philip DeFranco? Yes, Philip DeFranco. Yeah, that's what it is. I'm sorry. I don't know my YouTube personalities. If they're outside of the educational bubble, like, I don't know the YouTuber. Like, and even then, within the educational bubble, I don't know the educational YouTuber, you know? Like, it's just, it is what it is. I only know a select subset of people. Okay, so what are we doing today? As of last week, well, actually, we've been doing this GPU stream for a while now. You know, we've been doing, about 5 weeks ago, I believe, we did a stream, maybe even 6 weeks ago, we did a stream where we just introduced GPU computing with CUDA, right? And we said, okay, here is vector addition in CUDA. Immediately after, we did vector addition in OpenCL, and we showed the differences between the two languages. Since then, we spent about 3 episodes kind of introducing vector reduction, which is basically parallel summation, which is an interesting problem because parallel summation is very, very hard to, I guess you could just say, do in parallel. Because the idea is that we have one element added to another element, added to another element, to another element. It's basically a sequential addition, right? If we're summing an entire vector. And this is hard to do in parallel, right? So we showed ways to speed it up, all this kind of stuff. And then last week we went into the library that I use for research, which is GPUE. So this week I wanted to kind of switch gears a bit. Instead of doing stuff that I know pretty well, I wanted to move into stuff that I don't know very well, but could potentially be useful for the future of this stream. And that is JuliaGPU. So if you guys are not aware, Julia is the programming language that I have been using for most of my work here. I guess, I don't really know how to put this, but most of my programming life here on this channel for the past few months, I would say. And they basically have the ability to work with CUDA. I mean, Julia is a language predominantly made for HPC, high-performance computing, and obviously, as I said in last stream and a few streams before, a lot of high-performance computing is moving towards the area of GPU computing and even FPGAs and stuff like that. They're all moving towards new architectures. So these are the pinned repositories. These are the popular repositories in the JuliaGPU group. I know at least one of the developers in the JuliaGPU group. So this guy right here. So I'm pretty excited to see where it goes. In addition, for my future careers in academia, it's going to be very useful to know this kind of stuff, I believe. So it's one of those things that, sure, I don't know a lot about, but I'm willing to learn a lot for. What do we have here? YouTube.com. Let's take a look. Open link. Oh. Yeah, I don't have a good intro like that. I'm just me. I'm sorry about that. Maybe I should come up with a better intro. I'm just like, hello people on the internet, welcome to another episode of Simuleos. That's what I've been for the past few months. When I started, I was like, hey guys, welcome back to another episode. Today's going to be a wonderful day. So sometimes I say today's going to be a wonderful day. Sometimes I don't. It just depends on how the day's going. You know, it's 5 in the morning. It's been a super long day so far. So we'll see how it goes. As a note before continuing further, I might get an intro. No, I don't need an intro, man. I'm okay. I think in terms of YouTube videos, I don't really like intros on YouTube videos. I mean, with the exception of some people like 12 Tone, he's got a pretty good intro. Basically, like every time he starts his video, there's just a quick, 3 clicks. It's just like click, 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 and then he starts, And so it's enough to get you into it, but it's not crazy. And same with Wooden Potatoes. I think he's got a very good intro too. It's just like he says some stuff, then all of a sudden you see his Wooden Potatoes come up and animate, and then you go from there. We are actually animating the logo too. There's a lot of stuff to do there. Okay, so what are we gonna do? Oh yeah, the announcement that I was gonna say. So tomorrow is Christmas Eve my time. I know it's the 23rd of December for a lot of people here tomorrow, but the 24th of December. Oh my gosh, why can't I speak today? Tomorrow is Christmas Eve for me. I have the day off because today is the Emperor's birthday. And tomorrow is the day we celebrate the Emperor's birthday in Japan. So I have the entire day off, and I will be spending the entire day, or at least most of the day, basically here on Twitch streaming. And I understand that a lot of people will be going to bed at around 7 o'clock, as they normally do, because it's a late stream for a lot of people in Europe. But I'm going to see what happens if we just do a longer stream dealing with algorithm archive content. It's been a while since we've done something like that, and I really just want to see, not how far I can go, because I know my limit at this point in time for a stream is going to be basically 4 hours for the most I could do. Well, actually, yeah, probably 5 hours is about as much as I can do in a row, starting at 5 o'clock in the morning. Just because I need to eat breakfast and stuff like that. Let's see. What part of Japan do you live in? I live in Okinawa. Gathers, what is the text description below the stream? Why are you so ugly? Look, my mom always said you are what you eat. I hate an ugly person. My bad. Come on. Come on, that's funny. I'm sorry. It was an attempt at a joke. I understand that maybe cannibalism isn't the best types of jokes for everyone else, but for me, cannibalistic jokes are pretty good. In terms of my level, my quality of humor, like it's a peg above the bar I usually shoot for. Anyway, so that's all I wanted to say. Tomorrow we'll do a bit of a longer stream. It's not gonna be that much longer. Again, maybe 5 hours. It's not gonna be like an 8-hour stream because I do need to stop, eat breakfast, and stuff like that. And we'll see how it goes. And this outside of that, I like long walks on the beach, ice cream, and Linux. In fact, I use Linux almost exclusively. Yeah, it's fine. What's wrong with that? I mean, if you got a problem with my FAQ, I mean, I think I've got other. What else do I have in there? Chat rules. I use VI, yada yada, auxiliary info, computer specs, music, YouTube, contact, GitHub. Wait, where is my FAQ? Oh, it's right here. Can I link things in chat? Can I promote myself? Look, why is your code so ugly? Yeah, why are you so ugly? What's up with the cow? There should be a link to the spherical cow. Yep. Thanks for watching. Yeah. Yeah, I should probably update this description. It's been a few years since I had this down. Yeah, I need to update it. We'll update it in a bit. Okay. So let's go ahead and clear here. And let's CD back to the main directory, and let's just go. So we're gonna CD into projects, Simulaos, and I believe GPU. Yep, there we go. And we're gonna CD into projects, Simulaos, and of course GPU. Long walks on the beach, ice cream. That's what it was supposed to be. It was supposed to be a common thing. Like it's the stereotypical, like, you're introducing yourself on a date. What do? It's like, I like long walks on the beach, ice cream, and, devouring other people. Okay, that could be taken a bit weird. Okay, so let's go. So we're in the GPU. Let's take an ls and see what we have here. So we have parallel reduction.cu, vector addition.cpp, vector addition.cu. Let me just make sure everything's committed. Git status dot. The only thing that's not committed is reduction.pdf.xoj, which we don't want to commit. It's a kind of like a PDF document for only ugly people. Yeah, that's fair. So reduction.pdf.xoj is the only one that's not committed, which is fine. This guy is just, here, I'll show you what it is. What is it? Zernal. It's just notes on top of, yeah, it's just notes on top of this PDF. Oh, sorry for the yawn. Yep, so we just added some notes here. That's all we did. Man, my handwriting's amazing, isn't it? Okay, so now we're gonna work on the next thing. Which word are you replacing? Wait, what do you mean, which word are we replacing? Oh, for Gathros? I believe only ugly people, not on only people? On ugly only? Okay, so let's pop over here and let's talk about what we're doing. So we have this technical preview, native GPU programming with CUDA native.jl, and this is predominantly what I want to be using for this stream. Now, CUDA native.jl was recommended to me a while ago by a friend of mine who was basically working on it. So honestly, you know, maybe he was a little bit biased when he was talking to me about it, but that's okay. It's something that I worked a little bit with a while ago, and now I want to work on it again now. So I'm completely new to this. Basically, I'd completely forgotten basically everything that I needed. But as you'll notice that this guide is mainly made for Julia 0.6 pre-alpha. We are now at Julia 1.2.0.dev. And now if you want to get Julia or the CUDA native package working on your Julia installation, one thing you have to keep in mind is that you probably want the latest Julia version. You want, just because CUDA native.jl doesn't work on anything that doesn't have a working LLVM build. So you've got to make sure you do have a working LLVM build, which is easiest to do if you build it from scratch. However, I do believe that the latest binaries that are provided by the Julia development group, I think that these also have LLVM built in, but this depends on what you're looking for. Speaking of Tinder, okay, I'll take a look, but I don't know if I can watch this video. You're screwed. Oh, that intro. I remember that intro. That was pretty fun. Let's clear here. Okay. Technical preview. So let's go ahead and talk about what this is, where we're going. We'll just kind of move through this bit by bit and see how it goes. Hopefully it goes okay. So after 2 years of slow but steady development, we'd like to announce the first preview release of a native GPU programming capabilities for Julia. You can now write your CUDA kernels in Julia, albeit with some restrictions, making it possible to use Julia's high-level language features to write high-performance GPU code. So here they're already talking about restrictions, but I don't think it's actually that restricted. I think for the most part, you have what you need. The programming support we're demonstrating here today, consists of low-level building blocks, oh my gosh, I cannot even read, sitting at the same abstraction level of CUDA C. You should be interested if you know or want to learn how to program a parallel accelerator like a GPU, while dealing with tricky performance characteristics and communication semantics. You can easily add GPU CUDA support to your Julia installation by installing CUDA native.jl. This package is built on top of experimental interfaces to the Julia compiler and the purpose-built LLVM and CUDA drv.jl packages to compile and execute code. All this functionality is brand new and thoroughly untested, so we need your help and feedback in order to improve and finalize interfaces before Julia 1. That's what we're talking about here. Okay, so again, this is written in the past. I'm hoping that syntactically it still kind of follows, like it still more or less works. So we're going to see what we get. It says git checkout 0.6.0 or any later tag, so I'm hoping that this guide works. This was actually the most up-to-date, I guess you could say, Julia GPU guide I could find, but maybe there's another one out there. Let me see if I can just find CUDA native.jl guide. What am I looking for here? Any good links for the basic syntax of Julia? This is something actually, actually, let's take a look into that right now. So we'll look at actually Julia documentation. So, oh my gosh, why can I not do anything today? Just can't type, can't speak, can't even like think straight. So they do have this documentation here. And I think in general it's okay. But I don't know if this is exactly what you're looking for. I know a bunch of languages, Julia is not one of them. I would say that this is generally okay, but I do think that it could be a bit better. So there's like a syntax guide down here. comprehensive overview of all documentable Julia syntax. It's a bit weird. Like, you need examples, which I don't think. Oh my gosh, come on. I mean, they have arrays over here. I mean, I think it's okay. I think this provides all the necessary functionality you need. It's just, we don't have like good examples of what good Julia code looks like, and I think that's the big problem with this. I will say that Julia documentation has been improving a good bit recently, and that this is much, much better than it was like a few years ago. A few years ago, there was just very little. Have you had your coffee yet? I actually don't drink coffee. I know that sounds weird, but I don't know. Like, caffeine weirds me out in a way. I don't really know why. So let's look up CUDA native.jl intro. And let's see what we can. Technical preview, parallelized distance calculation, JuliaCon 2017 technical preview. I'm pretty sure this is about the same. Technical preview native. Yeah, this is literally the same. This is the same article we have over there before. It's just for some reason written at a different place. Is this even legal? Vector edition? What do we have here? Arrays technical preview. How to get started. Yeah, it's literally the same article. Down to the benchmarks that we have down here. Okay, fine, whatever. Let's just keep going and see how far we get. At this time of year, hot chocolate is my go-to. Dude, hot chocolate. So, okay, I'm not gonna lie. My parents just sent me a package yesterday. Or rather, they sent it probably a week ago, but it just came in yesterday with a whole bunch of like cookies and hot cocoa and stuff like that for the holiday season. So I'm pretty happy with that. I had been making cookies, which is great. You know, I enjoy making cookies. I made cookies that my grandmother gave me a recipe for. I made some M&M cookies. I made some really good chocolate biscuit things. You know, this is kind of what I do. Unfortunately, one of the cookies that my parents sent has peanuts in it, and my roommate is deadly allergic to peanuts. So luckily, he's not here right now, and I can eat the cookies until he gets back on the 31st of December. But yeah, it's I gotta eat all those cookies before then. But the let's see, the other cookies that they sent should be fine. But yeah, so just sent hot chocolates, just sent cookies. So it was a good care package, you know, and candy canes, because I freaking love candy canes. I'd been saving up candy canes for the Christmas, like for the day of Christmas, because, you know, winter without candy canes is just not a good winter. But you live in a tropical island, it's not the same in a cold place. I agree with you there, completely agreed. It sometimes gets cold enough, but like as you can see, even now, like it's early in the morning, my air conditioner is on. Like I actually have this set to 23 Celsius because it's just too hot in this room. So I totally agree that it's different in Okinawa than it would be in Canada, you know. But that doesn't mean I don't like hot chocolate. You know, it's still nice. Okay, so how to get started. CUDA native.jl is tightly integrated with the Julia compiler and the underlying LLVM framework, which complicates versions and platform compatibility. For the preview, we only support Julia 6 built from source on Linux or Mac OS. Luckily, installing Julia from source is well documented in the main repository's README. Is that true anymore? I feel like it's not. Oh, maybe it is. Yeah, fine. I'll give you that. When you're cold and you have something warm. Yeah, I understand. I really actually like cold places. I know I've always lived in a warm place, so maybe it's just, you know, I like cold places because I've never lived in a cold place. Like, I've never lived somewhere that it snows regularly. Yeah, it snowed like maybe once or twice a year in Alabama, if you're lucky. But for the most part, it doesn't really snow. It doesn't really get cold, you know. And then I move here, and it really doesn't get cold. Like, it hasn't snowed in years down here. Admittedly, we're about the same latitude as I was in Alabama, but I would really, really like to be in a bit colder weather. Canadian Sean, actually, not gonna lie, I would, username checks out. I've been wanting to go to Canada for a while. It's overrated, I like warmer places. I don't know, like, I overheat so quickly though. Like, I really do like colder weather. I like being cold. Now, admittedly, I don't know how cold I like being because I've never really been somewhere that is actually cold. But I do actually really like cold weather, and I absolutely hate hot weather. Hot weather is the absolute worst. Because like in cold weather, you can put on more clothes, you're fine. You know, you put on a jacket, you put on, you know, a sweater, you put on all this stuff. You can even be trendy with the clothes you put on, you know, and you can make fashion statements and stuff like that. When it's hot outside, the only thing you can do is remove your clothes. That is it. There's nothing else you can do. Because at some point, you know, you don't have air conditioning, or air conditioning can only take you so far. And a lot of people were like, oh, you shouldn't use air conditioning. And I'm like, screw you guys. No, you shouldn't use heaters. I think heaters are a waste of time. But air conditioning is essential. You know, without air conditioning, you simply cannot survive in hotter places, or at least I can't. You know, I start sweating at 24 degrees. Anything hotter than 24, I am at the threshold of starting to sweat. So I really think that, let's see, you like to think you hate cold weather, but when you get here, you suddenly hate it? Maybe. It snows here in Florida. I'm preparing for an apocalypse. Yeah, I hear that it could snow a bit. There's an interesting video where I was comparing UK to Australia for heat waves. Yeah, so, again, oh yeah, I think I know which one you're talking about. They're basically saying that the UK is like totally and completely unprepared for heat. Meanwhile, Australia is unprepared for like cold weather and stuff like that. -10 Celsius, welcome to Canada. I'm not gonna lie, that sounds really nice. Like, I know, I'm coming from a place of privilege where it's always hot, but man, I love cold weather. Like, it's just something I've always enjoyed. And I've always wanted to live in somewhere that's a bit colder, you know? -10 September, maybe? I don't think it's -10 in September. I'm pretty sure in September it's okay. Or like maybe +10 Celsius. But again, like, this is fine. I like the colder weather. Like, I don't know. I'm one of those guys, though, like, in the South, where I'm from, like, I genuinely do not use heaters. I think that heaters are the worst thing in the world. Air conditioners are fine, but heaters, like, I just don't understand the point. All they do is make you sweat. Like, it's just completely useless, you know? Like, and I understand, again, this does depend on where you live, but, man, it does feel chill with the right clothes, like my school uniform. Oh, yeah, fair enough. So in Japan, they don't actually use heaters and all their air conditioners are kind of like this. So they don't really use heaters during the winter, and they don't usually use air conditioning too much during the summer. So it's kind of, you know, they just wear whatever they need to wear for the day. How Australians are like 30 degrees Celsius, that's not hot, but they don't realize that the houses are built for colds. Well, -10 degrees Celsius in a good house is fine in the UK, and Australia is such a bad time. Yeah, that's fair. I think that's true for most places. I get cold when it's only 10 degrees C. I don't know how you guys handle it. Oh, no. I was kind of joking when I said 10 degrees C. I think for the most part, people get cold around 15 degrees C, something like this. It depends, but it's usually 15 degrees C plus or minus a few degrees. Some people down here in Okinawa, they get cold when it's like 20 degrees. And they're like, oh, it's so cold outside. It's like, I'm still wearing shorts. It's not that cold. And see, trust me, when it's 10 degrees C, you'll put on a heater. Yeah, I think people might, but I just don't like heaters. Like, I don't understand the point. Like, heaters just seem like a completely useless invention. Like, again, coming from someone where it's never really that cold, like, let me check the temperature in Okinawa today. It's probably like 20. It's probably like 20 or something like that. Let me see. I know it says, yeah, so it's 20 right now, and it's going to get up to 24, I think, something like this. And again, this is a cold day. This is like, in the summer, I think it gets up to 30. Honestly, the temperature here never gets too incredibly hot. It's always like between 20 and 30. I think the lowest it gets is like 15, and then it kind of goes in a range. Aren't there heaters under the tables in a kotatsu? Yeah, it could be. Yeah, I mean, there are, definitely, but we don't have those in Okinawa. Or at least I've never seen one in Okinawa. I think, but this is a bit different, you know, in Japan, like, because of the way they do the heating system, like, there isn't like a general heater for the entire house, you know, like, there's a heater here in your air conditioner, and then there's a heater, like, in the kotatsu, and stuff like that, but there isn't like a heater for the entire house, you know, like, there's no centralized heater. Which is what I don't like. I don't like centralized air conditioning either, I think. I think I prefer this air conditioning where it's like an air conditioner in every room. I think this is much preferred for me. In fact, I like Japanese architecture a good bit. I'm a big fan. Okay, so let's go. CUDA native, where were we? Technical preview, we were here. Okay. So let's go to the Julia GPU stuff. Let's start talking about this a bit more. I do understand. I mean, I also enjoy talking about the weather. It's nice, but it's also pretty stereotypical conversation. So let's see. What do we have? So let's go ahead and do our CUDA or Julia test. So I'm going to run Julia version just to make sure this is correct. This is incorrect. So let me just do source /bash rc, and let me do the same thing over here. Basically, I updated my path a bit, so we have the appropriate Julia version. And this should be okay. This should be 1.2.dev, correct? So let's run Julia. And we're just going to run using pkg, and then pkg.test. And we're going to test CUDA native. All right, and so I have the thing installed. I built it. Everything seemed to be okay. So let's just run these quick tests just to make sure it's okay. And then we can go from there. Oh, crap. There's an error during the test. Oh, no. That is not what I was hoping to see. Oh, crap. Is it still running, though? It seems to still be running, so hopefully this is okay. It's happening. I will delete my hard drive and set up Linux by Windows. This is... Okay, look. I'm really, really hoping that this is your choice and it's not like peer pressure from the community. But look, I'm very proud of you, man. Good luck. I don't know. Like, when it comes to operating systems, I know everyone debates operating systems and text editors and stuff like this. I mean, as sad as it is, this is what this is how it goes. What happened to the stream? Wait, is something wrong with the stream? I hope it's fine. No, I think the stream is fine. It still seems up. Alright, technical preview. Let's see what we got here. So we're testing the CUDA native package, and I'm hoping it works. I know we have an error, but I think it should be okay. We'll just let this test finish. Oh. Okay, Kappa, JK, I missed the Kappa for some reason. The stream's fine. Good. Whew. Bit worried there. So yeah, today's going to be a bit more casual. We're just going to chat, get the Julia GPU stuff working for Vector Edition, and hopefully there isn't going to be too much trouble coming up. What I want to try to do, since I do think I've been using Julia a lot for stream, I would like to start doing some future GPU stuff in Julia GPU if this works out. Don't get me wrong, I enjoy CUDA, I use CUDA for work, but you know, the problem with CUDA is there's just a lot of boilerplate, and same thing with OpenCL, there's a lot of boilerplate. If we can just use CUDA or Julia for most of this stuff, it saves a lot of time, and that's kind of useful. So I was thinking, you know, in the future, if we're able to switch most of our stuff to CUDA, Julia GPU, and we get the same performance benefits, we might as well do that. It seems useful. Ubuntu plus Visual Studio Code is my setup. It's not crazy low level, but I have apt, which is also nice. Yeah, it is definitely nice. Having package managers is super nice. Like, I don't understand how people work without package managers. It's the one thing that just, how do you live without a package manager? You sounded like you destroyed your PC, so I had to make the joke. Oh, no, my PC's fine. I think so. I'm just waiting for this test to finish. I probably should have done this yesterday. It's using, it's not even using that much. It looks like it's using 5 gigabytes. Wow, really? I'm using 5 gigabytes of RAM? Oh no, oh no. Some tests did not pass. 200. Okay, I'm hoping this is okay. It says package CUDA native errored during testing. Now that's a weird way to put this, but maybe this is okay. Because it says 251 passed, 0 failed, and 1 errored, but 0 were broken. So let's see what the error package is. Error during test, Tomtains Julia package CUDA native, base.jl, got exception outside of a test. Method error, no method matching dump function. Whew. Yeah, I'm not gonna be able to understand this one at all. This is just way too far. But it does say 251 passed. So like, we've got, what is this? 0.05. Oh, 0.5% of packages errored. Not failed, errored. So it doesn't say any of them failed, right? We've got a 100% success rate if you don't count the packages that had an error. So maybe we're okay. Let's see. Package managers are good, or a godsend to programmers. Well, that's a lot of RAM. Yeah, I'm still using 421 gigabytes of RAM. 4.21 gigabytes of RAM. I guess that's just what OBS is using naturally, which is kind of crazy when you think about it. I didn't realize that OBS would be using that much RAM, but it is what it is. You know, stream That's fine. All right, we'll run the SL command over here just because I feel like it. I'm just going to assume that this is working okay. I mean, I realize we had this one error, but come on, one error, everything else passed. I can still do using CUDA native, using CUDA DRV. So like, we'll see how it goes. We'll see how it goes. Let's go ahead and clear here, and let's just do vector. Wait, what did I call the other ones? Vecadd.jl. All right, so we'll do a similar thing over here. So we're gonna say using. I know this is a bad start, but we'll try it. CUDA native and CUDA DRV. So that's the CUDA driver and CUDA native, and this should be okay. Can we directly look at the test? We can actually. I'm trying to remember how to do that. Let's see, 251 failed errors, home James packages, CUDA native sum test run test.jl6. So we can take a look at this, but there's actually a way to look at the code itself. Well, let's just take a look at it here. So let's go into VI, builds. Oh, okay. It's apparently in home James .julia packages CUDA native NQ sum. Let's see, test, and then run test.jl, and it says it's on line 6. So it says test set CUDA native begin. Well, that doesn't help me at all, does it? CUDA native error during test, package error. Let's see, where are we? Home James builds Julia user share Julia stdlib version 1.2 package source types.jl 20. It's saying package error. Let's take a look at that one because that's probably the error. So let's go into VI. Should be here. And it's saying it's on line 120. Package error, message string throw package error. Oh, come on. Test 66. What do we have here? Do you have a good learning source for Julia? The best learning source I have is actually this documentation. As the package itself is the error? Yeah, this is what I'm trying to figure out. I can't quite figure it out. So here we have the package error, but I don't know. It's not really giving me a good thing. Like, I don't really understand where to start here. So we'll try to figure that out. What do we have here? Keep it the main. I don't know how you got question bot LVM. Oh, LUYL. Loyal? I don't know how to pronounce that one. So they get posted in the Discord automatically. Package itself is the error. Yeah, I'm not really sure. So we'll take a look here. Package error. I'm going to just keep following this trace a bit and see if we can figure out what the error is. So let's go ahead and take a look at VI. Let's see, home James here. And it says it's at 1328. Hello. There we go. Again, it's just giving me a package error. It says something is empty. This doesn't really help. But it does say we have this problem. Home James builds user share Julia stdlib version 1.0 package source API.jl line 0. Honestly, I don't think I'm going to be able to figure this guy out. But let's keep looking at, see if we can find something. VI here. I believe it's this guy, and it's going to be on line 193. Operations test. Again, we're still just doing the test itself. These are all inlined. All these are inlined. Yeah, it's all inlined. Let's see. Test, let's see. Tuple of scope. We'll try API.jl. Where are we? We're API, I believe. Yeah, we're at the appropriate location. So let's try 173. Yeah, there's something wrong with the test here. I'm not exactly sure what it was. Wasn't there a different stack trace above the result? Yeah, it could be. Error during test home days. Base.jl. No method matching dump function. Let me see if I can just... Because it could be a difference between Julia 1.0 and 1.2. It could just be some syntactical difference between, you know, something like this. Yeah, I've got a feeling this is just going to be some weird syntactical error, but I've got a feeling that it's not going to affect our tests today. I think that maybe the issue is that I should have built 1.0.4 instead of building 1.2.dev, 1.2.0.dev, or whatever it is that I'm building now. So I think maybe it's just some weird difference between 1.0 and 1.2, and that the packages that I have for the the package that I've downloaded for CUDA native could just be at a different version than the Julia that I have downloaded to. I don't know. I think maybe we're okay. I think maybe we should just continue. I know it's kind of lame to continue with an error in the test and everything, but at the same time, I really don't know how to fix it. It's above my understanding at this point. Granted, there could be a time in the future when I know more about Julia development, but at this point, I'm still using it as a user, not necessarily as a developer of the language. At some point, I'd love to help with the development, but this is, pipe dream for the future, not now. Okay, so let's see. It seems like it didn't load properly, but if this is the only test that didn't work, I have no idea. Yeah, this is the only test that, I agree. It seems like it didn't load properly, but that's the thing, I can't figure it out. The stack traced above, again, let me take a look at this again. Yeah, this is definitely a different error. Let's see. At home contains Julia packages CUDA native test base.jl. I believe that's where the test is itself. So let's take a look at that. No, okay. So let's see if we can find that guy real quick. So it's going to be vi. Because maybe this is also another error. We'll see. It says it's on line 5, which is method caching begin. I don't know. This is kind of one of those things. I think it's just too complicated for me to look at right now. What I want to do is see if we can get this working, and then we'll see if we can figure out what the error is after that. So I think maybe that's how we continue from here. Sorry about that. There's just going to be errors that may or may not pop up. Okay, so basically what they're doing here is they're creating the first vector addition in CUDA for Julia. So we're going to do a very similar thing. Let me just create or move this. Move this over here so that we have the code right next to us, or I have the code right next to me, and then I'll kind of work on that. So we have using CUDA native CUDA drv, and then we have basically the function kernel vadd, which is vector addition. So we're going to say function kernel vadd, and we're just going to add a, b, and c. Okay, so here we notice an immediate difference between what we were doing with CUDA, and that there's no additional syntactical notation here to define what is on the device, what is on the host, and what is global between the device and host. Now, this is an interesting thing to keep in mind, but ultimately, I think it might be okay. I think the Julia compiler can figure out what's supposed to be on the device and what's not. So it says here, from CUDA native implicit CUDA device array type and thread blocks intrinsic. So basically, this is similar to what we had before. I is equal to block ID x here dot x -1 because there's an off by 1 error in Julia. Rather, Julia starts counting at 1, C starts counting at 0, so you have to subtract from 1. That's going to be the hard part, hard to get used to in my experience. I agree with you. I'm so used to having like a device and host functions and stuff like this. It's going to be a bit weird, but I want to take a look and see what this has to offer. Block dim here dot x plus thread idx here dot x. Okay, so this is exactly the same as what we had in the CUDA function. Let me just go here and just say c of I equals a of I plus b of I, and then it says return nothing, which is a bit interesting that we tell it to return something at all, and the thing that we tell it to return is nothing. So I'm not really sure what this keyword does in Julia. Maybe this allows it, I don't really know what this does, so we'll take a look at that. So let's compare this real quick to the C kernel, which we should have. Oh, actually, I don't have a terminal for it right now. Let me go ahead and open up a new terminal. And we're going to cd into projects, simuleos, GPU. That's going to vi vecadd.cu. Okay, so this compared to that, we have function kernel vadd. Over here we have global void vecadd, and here we have double star a, double star b, double star c, int n. Again, we're not explicitly defining our types, so by, I guess you could say, just sheer number of lines of code and sheer number of characters typed, this guy works pretty well. Maybe roll Julia back to 1.03 stable product version. Yep, I could do that, but not right now because it's going to take too long. It'll take like an hour to do so. I mean, I could just grab the Julia. So the issue is the following. Let me just go ahead and do... I do have a version of Julia on my system that is Julia 1.0.4 or whatever it is, a stable recent version. The issue is that by using that version, I'm not able to use CUDA native because I don't have an LLVM build. So I need to actually build Julia with LLVM inbuilt so that I can use CUDA native. Otherwise, I'm not able to do it. So I'm gonna have to rebuild Julia no matter what I do, and I'm just not willing to do that on stream because it takes like an hour, sometimes an hour and a half. So it's not worth. I think it's not worth redoing here on stream. I mean, I can show you the build process, I guess, but then the entire stream will just be me really rebuilding Julia, you know? Okay, so here's the difference between the two of them. We still have this int IDX, block IDX, block dimension X, thread IDX. That's the same thing here. We just have like an off by one error here, so we subtract one from it. But ultimately, same thing. Block dimension, block ID, thread ID. This is all in one dimension, so it's thread IDX. So what's the plan? We're continuing working on this. It should work. I don't think there's, we'll see if it works. I think it should work. Okay, so now we basically grab the device, which is going to be dev is equal to ku device of 0. So we're grabbing the first device here. And then we're going to say ctx is going to be equal to ku context. Now this is a bit different. I don't really know what they're saying is this context here. So I don't know what this ku context is because I'm not used to this at all. Hope the error test doesn't affect something we're doing. Yeah, that's basically what we're doing. We'll see how it goes. I think this error is probably fine because we're able to load CUDA native just fine. And if this fails, if this vector addition fails, then we know there's something wrong with the Julia installation that I have, and we can work on that. No, the error didn't break it. The error still let us run it. So we're still okay. I just don't really understand exactly what the problem is here. So we're going to do some sort of length, which is going to be equal to 512. And we're going to say A is going to be equal to rend. And these are all going to be int of length, right? So we're going to create a vector A. Is this still allowed? I don't know if this is still allowed. We'll see if this notation is still allowed in Julia or not. So now we basically allocate everything on the device. So let me just go up here and let's add some comments in here. So generating some data. All right, now we're probably gonna have to add a test in here to make sure it works and all that kind of stuff. So now we're gonna say allocate and upload data to GPU. All right, so we're gonna say DA, which is a device A, is gonna be equal to kuArray of A. So here we're basically doing our CUDA mem copy. DB is gonna be equal to kuArray of B. And then we're going to say DC, this is a bit weird notation, is similar to D of A. So I guess we're just saying it's the same structure. So we're allocating the memory, but we're not copying anything over. So a little syntax. Yeah, it is quite different. We'll take a look at the difference between this and what we had in CUDA afterwards. So now we're going to execute and fetch the result. So we're going to say at CUDA. Here, I think it means that we're using this on the device. We're going to say 1 to len. Now this notation I'm not so familiar with, but I'm guessing that this is going to be our length is going to be our block size, and 1 is going to be our grid size, I think. So then we're going to say kernel add, the add, sorry about that, DA, DB, and C. And C is going to be equal to array, sorry about that, DC. Okay, so basically kuArray brings it to CUDA. Sorry, I hit the microphone. Array brings it back. I'm not sure if I love or hate the end of every function. Yeah, I do agree with you there. I think having the squirrely brackets are actually my favorite here because this allows me to just move back and forth, right? So like if I had something that looks like this here, and let's just say here, then I can just very quickly find the start and end of every function. But because it says start and end, it's actually a little bit harder for me to figure out where everything starts and ends because it's all text. And I can't very easily just, go back to the start of the function very easily syntactically. Let's see, we have DC here. Okay, so now we're saying using base.test, which is interesting. Again, I'm learning a bit about Julia here. We are, capital T. We're then going to say at test, C is equal to A plus B. All right. And then we're going to say destroy context. Okay, there's a lot of stuff here that's a bit different. So what I'm going to do is I'm going to pop up our Julia shell and see if this runs. So we're going to say include, and I'm going to include vecadd.jl. Okay, tuple argument at CUDA has been replaced by keywords at CUDA threads equals, oh, okay. Okay, so at CUDA has been changed on line 23, but, and I don't know the syntax either. So I guess we're going to say, I guess it's just threads equals len. Is it working? I have no idea. So we'll give it a go, see what's happening. Undefined error, test not defined. Okay, well, if that was our error, let's just... Do I have base.test installed? Let's do using test. Maybe I have to do using... Oh, is it using base.test? Well, let's change this to just using test instead of using base.test. Include vecadd.jl. Error, C not defined. Ah, that's because I had a typo. Let's try this one more time. Vecadd.jl. Coup context. Destroy is deprecated using destroy. All right. Oh, okay. I'm assuming this is passed then? What do we have here? So, I don't know if I love or hate the end on every function loop. I have a tool that autocompletes a set of brackets when I hit enter. Yeah, I know, I have a similar thing. Visual Studio Code extensions are perfect for that kind of thing. Hey, Dresstalk, how are you? Hey. Oh, I'm late, but I'm here. It's okay, you didn't miss much. Okay, so this, I think, passed. Let me just do something real quick. So we're gonna say for I equals 0 to I equals 1, sorry, to len. End here, and we're just gonna say print line, and we're going to print out C of I, and then A of I plus B of I. All right, just to make sure this works, because I don't know, I'm just like sketched out by this test. So let's go ahead and do include vecadd.jl. Print line, point line. Let's try one more time. Print line. All right, let's go. Include, let's add a tab in there. Okay. Yeah, they do seem to be the same. So I'm relatively happy with that. I think it's okay. Thanks, Cube at the main. Change and see what happens. Yeah, that probably would have been a faster test. Okay, but they do seem to be the same. So let's just do here. There was an error during testing. Yeah, okay, fine. So it seems to be working. That seems to be okay. So what I'm going to do is I'm going to move this to the other desktop real quick, and let's just compare the C++ code to the CUDA or to the Julia code real quick. Now there's a few things here with the Julia code that I'm not very happy with. Like, I don't like this threads notation here. There has to be a way to define the grid also. In fact, I don't like this for a number of reasons. So let me see if I can modify this a bit. So what I want is this to be equal to length 1, 1, something like this. And let me see if this runs. Okay, that does run. So let me see if I can do grid equals 1, 1, 1, and hopefully this also works. No, okay, so I don't know how to define maybe block. Okay, so this seems fine then. So basically we have some specific keywords that we have to assign to our system that our system knows. And this should be ultimately okay. So now let's compare this to the C++ code. Okay, so we have vector add here. How many elements? Let's just use the same number of elements here. So we're going to say we have however many elements we have over here. Okay, and let's just do a quick run test of the two of them, just to see what's faster. I mean, they should be roughly the same speed because we're using the same device, but we'll see how it goes. Okay, so we have all the devices over here. Threads 100, 1, and then grid is going to be equal to. Okay, so we have let's actually change this to 100. Yeah, we'll do 100, and then blocks are going to be whatever this is. I'm not going to do the math here. I'm just going to put in the numbers. Okay, so that should be correct. Let's run the Julia code, see if it works. It seems to not give us an error, so we'll give that guy a go. Okay, so now let's take a look at the difference between the code. So first, let's start with the kernel up top. Like I said, the kernel doesn't really have anything inherently different about it, right? So we have a global thread ID. Here we have a check, which I don't have over here, so I guess I'll just add that check in. So we'll say if I is less than, oh, we're not even reading in an n, less than n. We'll have this defined, and here, and we'll add an n in here, where n is going to be equal to length. This is, I'm going to do some crappy notation here just because I don't really care. Gotta go, wish I could stay longer. I'll definitely have to check out the stream afterwards. Yeah, no problem. Thanks so much for being here, man. Okay, so here we have just changed our code a little bit. I'm going to add parentheses around here. I know the parentheses aren't necessary. I like parentheses. There's a weird terseness to the Julia syntax that I kind of, don't get me wrong, it's nice, but I like to have brackets around things. I don't know why. Okay, so now let's go down here where we're defining all the elements. So again, the function of the kernel is basically the same. We're comparing this to this. They're almost identical with the exception of the fact that we don't have this global in front. Now I think Julia fixes this by having this @CUDA command, which basically means that this function will be run on a CUDA kernel. And I think that's the big difference here. Now we have some stuff here where we're defining which device we're calling on, and we're calling a CUDA context. And I'll be honest, I don't really understand the notation here because I'm not used to this CUDA context. It's called being organized and readable. Fair enough, I do understand. Now with C++ and CUDA, you'll note here that we have all these mallocs and all these allocations and CUDA mallocs and all this kind of stuff. These are notably absent from the Julia version. So Julia underneath is defining our CUDA arrays and stuff like that with this QArray command, I believe. So this QArray command does the CUDA malloc and does the CUDA memcopy for us. And then I assume this similar here is basically a keyword that basically says, hey, look, we're allocating an equal amount of space on the GPU for this variable. We just don't know what this variable is like yet. And so I think this is also fine. So ultimately, we're saving a lot of syntactical hassle by basically just doing this. All right, that's super fast because this right here is essentially all of this over here. And that's cool. I think that's quite nice. So this does help us out a lot. Actually, no, it even does this. So all of this is replaced by just, 1 second, these lines here. So we're basically cutting those lines in half that don't use parens. Wait, don't use parens? Do you mean parentheses? Or, I'm not sure what you mean. Okay, so now we have, let's see, threads here. And again, we're defining threads here. So here, when we call the CUDA kernel, we're defining the thread blocks. I assume there's a way to do this in a more syntactically beautiful way, I suppose you could say. But here we have to do it anyway, right? So we're saying vector add grid threads. Here we're saying vector add threads blocks, which is basically the same thing. Then we do kernel v add here, calling the CUDA command, and then we copy it back to the CPU by using c equals array of DC. So I think this is kind of what we're working on. These things, yeah, parentheses. No, I think most things use parentheses, yeah. It's just that up here for the if statement, I didn't technically need the parentheses there. I could have run it without that. Okay, so we have CUDA here. I have that written. So I'm going to go ahead and compile this code over here. So we're going to run nvcc vecadd.cu. I think it should compile no problem. And let's pop over here and let's include juliavec.jl, just make sure it works. There is a load error out of memory. What? I don't get that with the C code. You failed. What a loser. Oh. Let's drop this a couple points. Maybe I just ran with a huge number of points just to show that we have a memory error or something like that. Let's try this again. Trolling myself. Let's do a.out. Pass the test. Congratulations. Great. And let's run the Julia code again just to make sure it works. No, it still gives us an out of memory error. Now that's quite interesting. Now let me see what's going on over here then. I don't understand why our C code would be giving us an why this one's not giving us an out of memory error, but the other one is. Okay. So, oh, it could be, I think it's the following. I think I screwed up here. Now let's try it. There was an error during testing. Okay. Well, let's try dropping this one more order of magnitude and just see if there's still an error during testing. Because maybe there's something different about... No, there's still an error during testing. In fact, I believe there's going to be an error during testing unless we do something like this. No, there's still an error during testing. What the heck? Oh, how are you still creating an error during testing? Okay, let's try changing this to 512. What's up? What's up with this error, dog? If I is less than n, maybe we delete this if statement? The heck? Why is there a problem here? If I is less than n... Huh. What do we have here? Hey, Nuffly, what's up? It does use... Rainfog doesn't, but that feels like cheating. Yeah, I guess that's fair. Julia, Rue happy? Yeah, I have no idea what the problem is here. Let's try thinking about this. Let me get a quick sip of water. Maybe I just put something wrong in there. If I is less than n, what? We shouldn't have a problem with this if statement at all. If I is less than n, so I should be block ID. Oh, maybe there's a -1 in here. What? How are you out of memory? What is going on? How? How are you out of memory? This if statement's just... What? What on earth? How are you out of memory? Okay, let's check your memory. CUDA... What is it? It's, oh, what is it? How do I check my memory going on here? NVIDIA SMI. Looks to me like I'm using... Oh, what the heck? What is going on? Julia, my dear Julia, what are you doing? What are you doing? Get out of my GPU. What are you doing? Oh my word. How are you using all my GPU memory? What was up with that? Alright, let's try this again. Julia, include vacadd.jl. Holy cow. And the stream was fine, like you guys noticed no problems with that. Oh my word, what was going on? You were using all my memory, dear Julia. 121 megabytes, okay. I mean, I don't understand why you're still using memory. All right, let's try getting rid of this if statement now. Include vector_add.jl. Test failed. Now let me check NVIDIA SMI again. All right, Julia, you're fine. Whoa, man. What were you doing? I saw your GPU and I just kind of took it? Yeah. What was going on there? Is this... What on earth? Ugh. I don't know if there's a leak or I just wasn't appropriately clearing my context. But yeah, that was pretty rough. It's still using my memory. It shouldn't be. Like, it's not running anything. Why are you still using memory? I'm going to have... Let me open up another terminal right here. And I'm just going to put it over here, and we're just going to watch NVIDIA SMI. Okay, so we're going to have it constantly watched over here on the side. And I'm just going to pop over here. In fact, let me run /a.out, okay? And let's watch to see what happens with the memory here. Oh, nothing, because it took no time at all. Meanwhile, the Julia fails. Fails for some reason I don't fully understand. Because it did just run. I swear it just ran. That ran. But it doesn't run with the if statement? What the heck? I have no idea what's happening. Oh my word, come on. Okay, so... What are you doing, Julia? It's slowly using more and more memory. Let me just Control D out of here. Ah, jeez. Ah, jeez. What is going on? Okay. Couple errors here with the basic vector addition. Vector addition. For some reason, this if statement is killing us. I don't know why. I have no idea why, but for some reason, it's killing us. And then also, for some reason, we're not appropriately clearing GPU memory after the code is finished. No, I don't think it's looping forever. I think the issue here is that we're just not clearing the context. Because if you go to, for example, the C++ code, let's just open that guy up over here. Vector.cu. At the bottom here, we always free and CUDA free. So what I'm guessing is that we're not appropriately CUDA freeing everything on the on here. So maybe nope. Okay. I was hoping they'd give me a bit more information here in this tutorial about how to free variables and stuff like that, but they didn't. So I think the big issue here is that we're running the code appropriately, but let me try putting this into a main function, and let me see if this does anything. So we're going to open this up, and we're going to say, we'll call it function, we'll just call it function main. I'm not going to worry about it too much. Main here, and we're going to end the function down here. All right, and I'm just going to put this into a main function. Okay, we're gonna pop down here, we're just gonna run main here. I'm gonna see if maybe this solves the issue. Julia include vec.add.jl. Oh, of course, because of the load error. Yeah, so what I'm looking for. So let's go ahead and update that so that the if statement at test not defined. Okay. Let's try this. Come on. Give me a result. You're only doing 512 elements, Julia. You're not... Oh, my word. Have to go. Art9K, thank you so much for coming. Raid your paper, chaotic few vortex dynamics, rotating boson condensates on physics archive. Oh, cool. I'm glad you you enjoyed it at all. So this paper was actually a lot of work for myself. Obviously, the first author, Tian Tian, Angela, Thomas, a bunch of different people, Lee, everyone was really working. The test involves clearing. Yeah, that's the thing. I think it does. But yeah, so I'm glad you enjoyed the paper. Obviously, we'll be making a new paper soon, or rather, there will be a new paper coming out soon on three-dimensional vortex dynamics. So feel free to take a look or look for that as it comes out in the next month or two. And we'll be working on that in early January. The test involves clearing. Yeah, I think it does. I don't know. I don't know what's going on at all here. So I'm just going to go ahead and write this. I'm going to this and that. Include vector add. Okay, so that ran. Let's check the Julia. Yeah, Julia's still using memory. And if I keep running this, I looked at it. I wasn't able to read the whole thing yet. Sorry about that, Cathros. Oh my word, Julia, what is your problem? I'm sorry, I've been super swamped. But luckily today I have time. Fist bump. So I can read a whole bunch of reports. I have this other guy who wants me to read the report too. Oh, Julia, you just keep using more and more of my memory and I don't know what to do. I don't know what to do at all. Okay, let me see if there's a new up-to-date guide on this CUDA-native.jl stuff. I don't think there is, but we'll see if we can find one. Oh my word, this is awful. Absolutely awful. So let's do, I mean, it's not that awful, I guess. CUDA native. Julia intro? But this is going to give us the same thing that we got last time. Initial split into CUDA native, CUDA DRV. Oh. It's like you're creating variables that you're not using. No, I mean, it's just the CUDA clear. Hey, I'm not Swak, what's up? How are you? Hey, fan? Thanks for coming in. Yeah, this is not going to do what we're looking for. Introduction to GPU programming, CUDA in Julia, sorry about that. GPU arrays never had to implement automatic differentiation explicitly to support the backwards pass of the neural network efficiently. Let's see. How does the GPU work? Using CUDA DRV. Function Julia set. Oh, I just want a simple vector addition. Huh. Sorry for the yawn. Hey. Gotta go soon. Want to say hi? I'm an intern. Oh, cool. Yeah. I hope you're enjoying your internship. Let's see. Looking for help if you find yourself in an abusive relationship with Julia. I don't think we're exactly in an abusive relationship. She's just stealing all my memory. It's just stealing all my memory. I should probably not. Let's see. You would think that there'd be just... I mean, don't get me wrong. These guys have... Is there just a vector addition? Vector. Nope. Nope, they don't have vector addition. They went all crazy with this. They don't have vector addition. Call the police then? I'm from Turkey. We don't have Christmas break. I'm sorry, man. We also don't have Christmas break over here. Like, I'm just lucky that we get tomorrow off because today is technically the Emperor's birthday. So we have 1 day off tomorrow. And we also get 3 days off at the start of January. January 1st, 2nd, and 3rd. She's into sugar daddies? I don't know. She's just into large GPU memory. What? She's into GPUs with large memory? I don't know how to put this. I think this is the same code that we have, isn't it? Yeah, it's the same code. This is literally the same. Why are they posting the same code everywhere else? They have parallel reduction, but again, like if we can't even get basic vector addition to work. Now I know if we run this here, I know it's not gonna stay in the memory, right? But this means that we have to pre-compile everything. It just takes forever, you know? So there's Julia finally starting up using 119 megabytes, which is a lot, versus here in C++. Boom, nothing. Literally nothing. And this is doing a very, very large number of elements too. Whereas CUDA is only doing, or Julia is only doing 512 elements. C++ is doing, I think, 100,000 elements or something like that. So, that is not looking good, and I'm not sure what the deal is. Hey JSPP, how are you? Most of the Turkish people are Muslim, so no Christmas break. Yeah, that's fair. It's not a big deal. Finally, great holidays. How are you? Oh man, no holidays for him is what he just said. Okay, so if you're just tuning in and you have no idea what's going on, we have just coded up a vector addition kernel in Julia, and this is the first time I've done so in a very long time. Before, I just wrote the basic kernel, but I didn't really do any testing. I just saw that it worked. Now, today, we basically implemented the kernel as it should be implemented, but after the implementation, we found out that, for some reason, it is continuing to keep variables on the GPU. In addition, syntactically speaking, some of the functions are not seeming to work with basic if statements, which should be in the CUDA kernel to begin with. So we're running into a situation where, I don't know. I don't remember anything, or I don't know how to continue. I don't know what the deal is here or how to fix the problems that we have, because I can't find good documentation for the CUDA native, native.jl repository. Because here is literally all they have. They have a package add CUDA native. The current version of the package requires Julia 1.0. Older versions of the package Julia 6.0 or 0.6x or older. Yeah, it doesn't really have any information here. CUDA native.jl is licensed under the MIT license. They have a paper. Sorry for the yawn. Yeah, I mean, we can take a look at this paper. I was about to save this. It's not open access. Oh my word. What do you mean it's not open access? Okay, well, let's try effective extensive unleashing Julia on GPUs. Okay. Just Google this. We'll probably find. Here it is on the archive. That's good enough, I guess. And let's see what they have. Oh, Julia, how much we don't know about you. Yeah, still super cool. Cool. Okay, so let's see, what do we have here? They might have changed the syntax a bit. Intersect, yada yada. Generated function load, LLVM convert. No, this is the underlying details of how it works. I'm looking for a simple example, just a simple vector addition. Oh, here it is. Oh no, this is the C CUDA. Yeah, this is fine. Simple vector addition in CUDA C. Here it is, vector addition in Julia. Grid block, SH memory. Load code generation from the @CUDA invocation listing 6. Okay, so this is what's generated. Okay. This is the code we have, and we're running into issues with it. I don't understand what the issue is, though. But see, the problem is here. They didn't have the if statement in their kernel up here either. Like, are they putting wool over our eyes? I mean, like, let's see what they say for GPU time. So they're saying CUDA C is still slightly faster, and CUDA C is also, yeah, CUDA C is still slightly faster than CUDA native.jl. Let's see, what do we have here? Let's see. The project task they gave me was easy for me until yesterday. Yesterday I had problems, spent over 10 plus hours on it, like 13 hours, I guess. Yeah, I've been there. It happens. And you get free days other times, right? Let's see. We got winter holidays on January, which is 15 days. Oh, that's quite nice. We also have weekend holidays, if that counts. Yeah, that's nice. Also summer holidays, which is 3 months. Yeah, that's super nice, actually. What are the symptoms so far? What do you mean, what are the symptoms so far? There's no if statement. Yeah, I know, right? In some old times, we had parts of Germany 3-month summer holiday as well for schools. I slept at 2 a.m. last night, was trying to solve it, but didn't solve it till 2 a.m. Yeah, man, I've been there. Slept and solved the problem on my nightmare. I've also been there. Back when I did research as an undergraduate, man, I used to be up until like 4 in the morning, just like trying to solve this problem. So like I would actually take the conference room and I would just plug my laptop in, so I had this giant screen to code on, and I would just code. Because I had this crappy laptop at the time that I wasn't really able to work on. So I'm a high school student, that's why it's 3 months. Oh, fair enough. Okay, so in their example here, they didn't really provide. Oh, sorry for that. Man, I'm so tired. They didn't really provide any real. This is the same code that we're working with, but they're not. Maybe I should just contact the developer. I know the developer. I know he's a nice guy, or at least I know one of the developers. The main issue I have is the fact that it's keeping the variables in device memory even after the function is finished. And I think this is maybe okay because we're running it in the Julia REPL, which basically means that, you know, we're in some sense keeping the variables on the GPU, you know, like because we're keeping it up in the command line. And maybe this is fine. But so maybe that's fine because when we close Julia, we no longer have the variables in the GPU. But the fact that I can't put a simple if statement into the function here is a bit disconcerting, right? Because here, let's just run it. So here's with the if statement out. So this if statement is basically checking to make sure that I is less than n, where n is the maximum number of elements allowed on our system. So that basically means that if we accidentally grab elements that are beyond what are allowed, then we just say, look, we don't count these elements, right? So this if statement does deserve to be there. It needs to be there. But if I run julia vec_add.jl, I believe I get an error. Come on. It takes forever to run too, which is another thing that I'm not super keen on. Yeah, so it says we have an error. But now if we remove this if statement, we just don't have it at all. Maybe this is a problem. Maybe there should be an n+1 because we're off by 1. I don't know. We'll see. Why are you taking so long to run, Julia? That one worked. Okay, so we were off by 1. Okay, fine. Fair enough. We were off by 1. Oh, I'm sorry about that. I just hit my desk. What do we have over here? I slept at 2 a.m. Solved the problem at 5 p.m. Left the computer, grabbed some breakfast. Yeah, I've been there too. I'm a high school student. That's why it's 3 months, by the way. I just got to the stream. I was wondering what the current problems are. Yeah, so I'm sorry about that. Here's the issue. We have 2 current problems with our kernel addition in Julia. Okay. The first one we just solved. Basically, we're off by 1 in this if statement here, which is dumb, but it is what it is. I tried not by 1 by doing n-1 before, but I should have done n+1. I should have thought about that. Okay, outside of that, we're also running into the following issue. So let's just run Julia. Hello, Julia. Here, and I'll show you the other issue. The issue here is that if I include vector_add.jl, it runs just fine, not a big deal. All right, but what I'm going to do is I'm going to watch the CUDA memory here. So here we say Julia is using 119 megabytes of memory. Now it's using 121 megabytes of memory. If I include this again, and again, and again, and again, and again, and again, right? I just ran the code again and again and again, right? But now it's using 492 megabytes of memory. And if I keep running this, basically the variables are never cleared on our GPU. So now it has 737 megabytes of memory, and it's just using up my memory like crazy just because it can. And there isn't really a reason for it. It's using up my memory. It's just storing variables on the GPU just because it can. And I don't know how to clear these variables. That's the big problem. Anti-Hyde, thank you so much for following. I apologize, I missed that a few minutes ago. So now we fixed one issue. Now we need to figure out the other issue, which is why Julia is just keeping the variables on the GPU, and we're not really able to clear those variables. I mean, maybe there is a way to clear the variables, but I'm not sure what that way is, because the documentation for the CUDA native.jl package is very sparse. It's not everywhere. It's not there. So that's the next problem that we have, and we're hoping to fix that. 2 common errors in CS: pointers, memory management, off by 1 errors. Yep, so we have one of the 2 errors. The testing error is the only thing I can think of. So you're saying if we don't have the test here, just go ahead and comment that guy out. Let's try running this. Come on. So there's Julia. It's finally booting up. Yeah, I don't think this is solving the problem. Hello. Yeah, I don't think that. Okay, wait, let's do Control D. Let's open it up again. Okay, so what do you mean by testing? So let's take a look. Is it a variable actually stored in the GPU, or is it a proxy of some sort that the REPL keeps in system memory? I think there are 3 common errors in CS: pointers, memory management, off by 1 errors. By the way, I'm migrating a Simbot now to an actual server, the same question bot is on, so it doesn't crash anymore. It's fine. It's okay. Okay. I think it's okay that Simbot's down sometimes. It's not the worst thing in the world. I mean, it's nice when it's up, but it doesn't have to be up all the time. That single error was present. Wait, what are we talking about here? It's a bit annoying, but that's okay. It's not a big deal. Okay, so what we need to do then is figure out how to clear variables from the GPU with CUDA-native.jl. There should be a way to do this. There should be like a CUDA free command or something like this. So let me see if I can find that. So CUDA free Julia. That's what I need. Because honestly, without the CUDA free command, it's very difficult to do anything anyway. GPU gives no performance improvement in Julia set. Understandable, but that's not what I'm looking for. Julia Lang, maybe? Performance view of CUDA arrays. Yep, this is okay, but what I'm looking for is specifically CUDA free. Let me see. General CUDA free. Can I just run CUDA free? CUDA free? Huh. Maybe it's CUDA free? What is KNetGC? The single error that was present. Yeah, so the test, we fixed the test. So the test is now, the issue was that we had an off by 1 error in the if statement, which is fine because Julia starts counting at 1. I should have known we have to offset everything by 1. That's okay. So we found that error. Now the question is, how do we free the variables from GPU memory so that we don't use the entire GPU just to run one simulation? And I'm not really sure here. So this is what I'm going to look into. So let's see, CUDA native.jl, CUDA free. Let's see if we can find something. CUDA free is not free memory. The memory is not cleared. Okay, this is not exactly what I'm looking for. CUDA free, maybe I should specifically say Julia Lang. Take a preview, verify reduce.jl, initial split. Free? Nope. They don't talk about freeing variables. Maybe it's in here? CUDA free, CUDA free, CUDA free, CUDA. Nope, that's the only time they. Oh, wait. They have a CUDA call. Let's try that. So let's go in here and let's just do CUDA call. And we're going to call CUDA free of DA. And let's just try this for DB and DC. Okay. And I'm going to leave this test in here. Okay, so now we're going to try include vecad.jl. See if it runs with the CUDA freeze. And I'm okay if we have to do that. Let's take a look here. CUDA free not defined. Okay. I'm writing some code that calls CUDA. GPU memory is managed through the garbage control, and although in directory. When CUDA array instances go out of scope and they are collected by the Julia garbage collector, the GPU memory ref count is lowered and freed. If it drops to 0. So make sure that your arrays are out of scope before calling GC. So I just called GC. Okay. Okay, come on. There we go. Of course it's not. Let's see. Let's see, you can force an early collection by calling finalize on an array. Let's see, function gc.gc. Oh, do I have to? No. Is it? Let's try. Okay. Well, I've never used that before. See what happens. Oh no, that clearly didn't work. The GPU memory is still increasing. Ha! That's okay. That's okay. We'll figure it out. Okay. Hey, buddy. Wait. Hey, Buddha Eyes, how are you? Okay. So, yeah, I have no idea what the problem is. Why do we keep the variables? Like, we're doing a context clear, right? So I would expect that in the clear context, I don't even know what a CUDA context is, in principle. Like, I don't know what we're talking about here. So I figured that this would be creating, like, some sort of instance that we then clear at the end, you know? But we're clearing the context. And clearing the context doesn't seem to get rid of the variables. Let's see, vector addition in CUDA. Oh, what are they doing here? Oh, what is up with this? They have a CUDA call command. I see. They're doing it slightly different than what I was expecting. So CUDA call kernel types. At CUDA. Yeah, I don't know where they're clearing their variables. This is kind of a big problem. So let's see if we can figure this guy out. Kuray. Fine. Yeah, so I don't think we're going to be able to figure out the solution here. I think we might just have to call it quits. CUDA native.jl include verify and reduce.jl initial split. Running for loops on GPU, of course that's a bad idea, but it doesn't matter. Support loading variables, values through texture cache. Effective extensible programming, Alicia Julia on GPUs. This is the exact same article that we're looking at now. I just don't think there's enough documentation here for me to figure out the solution here, which is dumb because this is a super simple thing. Prepared a cup of coffee. Alright, well I'm glad you're enjoying your coffee. Let me get some water here and let me think about what we need to do. So obviously the problem is straightforward, right? The variables need to be freed. That's the simple case, the fact of the matter. We need to free the variables. Now, we could try doing a garbage collector, but we just ran the garbage collector and it didn't seem to find the variables on the GPU. I'm okay, CXK. How are you? Let's see. It could be the REPL that's borking it up. Yeah, I do feel like it could also be the REPL that's doing it. But, I mean, in the code itself, we have this destroy context. Let me see if I put this beforehand. And let's just open up Julia and then run it in the REPL. And then we'll see what we can go from here. Because if we don't run it in the REPL, then we're actually hitting a huge performance cost. Because by not running this in the REPL, yeah, that didn't help at all. Bah. Darn. So by running it in the REPL, we run it once, and then running it a second time means that we don't have to pre-compile all of our code, so that's where we get the performance benefits. Because otherwise we can't really do a test versus like Julia and C, because honestly we're not going to be able to really be getting the same code. Does that make sense? Because if we run just Julia function.jl or Julia file.jl, this will do a lot of pre-compilation and stuff like this, which will make the runtime way slower. I mean, Julia is supposed to do garbage control by itself. You probably need to force the variables out of scope. Yeah, that's a question. I don't know how to do that. I don't know how to do that at all. And I'm not really sure. Not sure how to do that. I just don't know. Technical preview. Let's take a look at this technical preview and see if they give us any more information that I'm missing here. So let's see, how does this work? Most of the example does not rely on CUDA native.jl, but uses functionality from CUDA drv.jl. This package makes it possible to interact with CUDA hardware through user-friendly wrappers of CUDA's driver API. For example, it provides an array of type QArray to take care of memory management, integrates with Julia's garbage collector, implements at elapsed using GPU events, etc. It is meant to form a strong foundation for all interactions with the CUDA driver, and does not require a bleeding edge version of Julia. A slightly higher level alternative is available under the CUDA ART.jl. Oh, CUDA RT.jl, sorry about that, building on the CUDA runtime API instead. but it hasn't been integrated with CUDA-native.jl yet. Meanwhile, CUDA-native.jl takes care of all the things related to native GPU programming, the most significant part of the generation GPU code, and essentially consists of 3 phases: interfacing with Julia, interfacing with LLVM, and interfacing with CUDA. Yeah, all this is hidden behind the CUDA call. Yep, this is what I figured. Let's take a look at the parallel reduction. Inline, let me see if we have any CUDA error, fprintf, this is fine. Inline void, inline divide. What? What is this? This is just C++ code. What? This isn't... Oh, it's reduced.cu. I see, that would be the problem. Let's have a look. Julia version of this algorithm, that's what I'm looking for. How did you decide to do GPU computing? So GPU computing, I don't know how to put this. So basically I came to OIST, and when I came to OIST, I was looking for a sufficiently complicated numerical problem to tackle. You know, any type of really difficult numerical problem, that's what I was looking for. And GPU computing happened to be something that one of the people here was doing. Oops, I just turned off my monitor on accident. I'm hoping you guys can still see me. Let's see what happens when the monitor turns back on. But yeah, so the GPU computing just happened to be what I was interested in at the time. It allowed me to do some very complicated, I guess you could say, numerical computation for scientific computing, and it is the future direction, or at least was the future direction, of scientific computing at the time. And so it's one of those things that I was very interested in. Have you considered upgrading your GPU? So the GPU I use here is kind of crap. I just use it for basic testing. It's not really meant for anything. The GPU I have at work is really, really good. The GPUs, plural, I have available on my high-performance computer that I use at work are top of the line. They're the best you can hope for. So honestly, I don't need to upgrade my GPUs because I have really good ones available at work. What are numerical problems on GPU computing? We're talking about massive parallelization of any real scientific computing problem. So physics, chemistry, biology, all this kind of stuff. It's all basically there in GPU computing. So the idea is pretty much most people who are doing scientific computing are now moving on to the GPU so that they can perform their computation faster. And this is the idea, right? So we're taking our GPU and using it for computation, and that's basically any problem that you can think of that's easy to split up into little elements. That's kind of what we do. We put that on the GPU. Let me see if they have a reduce warp, inbound sync threads. Ooh, nice. Okay, so they've got a lot of stuff in here. The question is, do they have a CUDA free? They do not. Clear. They do not. I have no idea, which is a bonus. Plus it got signed by Linus Tech Tips. Oh, nice, which is a bonus. Yeah, fair enough. I don't need a better GPU for this computer right now. I mean, in principle, I probably could use one, but it's fine. The one I have right now is fine. It does all the testing I need to do. It's an older GPU model, so I can just test to make sure that the code base that I'm working on works on older cards, all this kind of stuff. So there's a bunch of just little things here and there that's useful. I don't mind having this GPU for this computer because, again, at work I've got some Titan X's. I also have P100s, V100s, K80s, M20s. I've got any type of card that you need. I've got at work. Here on my own personal computer, I just use 970, and it's fine. I'm not too worried about it. Okay, so I have no idea how to fix this problem at all. I just don't know. So I guess we can leave it. I'm just gonna have to ask someone. I think that's what I'm gonna have to ask. How much parallel speedup can be done with a GPU? I'm not too well versed with it and have always viewed it as a sort of matrix multiplication on steroids, but I assume more fancy stuff can be done as well. Yeah, so let's just go to GPUE JOS real quick. Release publication. We actually have a link here, so let's just go to actually GPU graphics here, and there should be a link here in the paper. Let me just scroll down real quick. Hopefully I can click. Yeah, so it should be second order. Wait, what do we have here? Comparing 3, this guy. This is what I'm looking for. Okay, so here's a quick comparison between our code base and other code bases. So again, it's just a super quick example. Here's the image I usually look at, view image. Scroll in. Okay, so GPU is our code base, Charter Suzuki MPI, GPU is their code base, CPU is their code base, and GPE Lab is a MATLAB implementation. So this is in log scale. So the MATLAB implementation takes about 1,000 seconds to do a simple Schrodinger equation in 1D. We'll say maybe 1,200 seconds, something like this. The CPU code, when it's well-optimized CPU code in C++, you already see huge speed up here. So this speed up is going from taking 1,000 seconds to taking 100 seconds, almost 70 seconds or something like that. So we're seeing a huge improvement here. Bringing it to the GPU, you see going from 70 seconds or 50 seconds or something like this, going all the way down to 10 seconds. So we see a 5 times improvement of generally well-optimized CPU code moving to the GPU. And we see about 200 times improvement moving from generally well-optimized MATLAB code to GPU code. So here we see a huge improvement on the code base. And you have to remember that this code on the GPU is running for maybe 24 to 48 hours. So if we were to run that on the CPU instead, that's 5 times as slow. Then we're taking that code that runs in 24 hours, and now it takes, well, a week to run, right? And that's not okay, right? Taking a whole week to run one simulation is kind of garbage. If we were to do this in MATLAB, it would take literally a month or something like this. It'd take way too much time, right? So moving to the GPU allows us to get, yeah, sure, maybe just an order of magnitude faster, but that order of magnitude is incredibly important when your code base is running for 12 to 24 hours, you know? Why is a GPU faster than a CPU? Let's see. What GPU computing is, you solve problems using GPU instead of CPU. Yep, that's correct. So the GPU, and I've covered this before in a previous GPU stream, but basically the GPU is different than the CPU because the GPU has a very large number of smaller cores, right? So it's got thousands of smaller cores, whereas the CPU has maybe at most 12 very large cores. So the CPU works on tasks that are inherently serial. By that I mean tasks that you do one thing at a time, right? So if you do one thing and then the next thing and then the next thing, this is good for CPU computation. But the GPU has thousands of smaller cores that does everything in parallel, right? So if instead of doing one task and then the next task and then the next task, you rethink about your problem such that you can do 1,000 tasks at once, if you can rephrase your problem in this way, it then works better on the GPU. Does that make sense? So the GPU, because it has so many smaller cores, if you can split your problem up into a whole bunch of very small parts, you can then put it onto the GPU and you get this massive speed up. And so that's the difference here. The CPU is good at serial tasks, things that you have to do one at a time. So anything you can basically put into a for loop, really, that's kind of something that you want on the CPU. But if you can split up that for loop into a whole bunch of individual units of computation, then you want that on the GPU because you can do it all in parallel. So I think it's some kind of floating number processor on steroids. Yeah, however, for K80s, P100s, and V100s, there is some good double precision support too. It's not necessarily just floating. Let's see, what do we have here? JSPP, do you still work? Yes, I still work. That makes a lot of sense. Thanks a lot. Really helps. Yeah, cool. That's kind of what we're talking about there. So again, as far as my code base is concerned, it's one of the fastest ones doing split operator method that we know of. So it's pretty good. And again, there's more information on that link that I think I just posted. No, I didn't just post it. So here's the link. So again, if you're interested in taking a look at that, please feel free to do so. I implemented Mandelbrot in OpenGL. Dude, amazing. Super fast. Yeah, of course it's super fast. It's OpenGL. Everything in OpenGL is super fast. But OpenGL is also slightly different than OpenCL. So OpenGL is more computer graphics, whereas OpenCL, I would say, is GPU computation. There's just a very thin line between the two of them. And honestly, the differentiation is kind of vague. You know, I say that OpenCL is for computation because it doesn't do graphics. Meanwhile, OpenGL is for graphics because it does do graphics. But then again, you can still do computation with OpenGL shaders, so it doesn't really matter. Oh, OpenCL, my bad. Then you're right. You're right. That's definitely GPU computation. And it is super fast. Literally everything to do with GPU computation is super quick. except for this weird Julia vector addition kernel. What is your problem, Julia? Why are you so slow? Why are you not freeing my variables? What is going on? Okay, so here's what I'm going to do. I'm going to increase, see, I can't even, I wanted to do a performance test between Julia and C, but I can't even do that because if I run the code in Julia, it's just going to run out of memory. Oh. Okay. So we got to figure out how to clear this variable, and I can't really figure it out right now. So what I'll do, knowing that we have a problem with the Julia vector addition code that is not appropriately clearing the variables on the GPU, what we might do is we might still run a performance test and just be sure to close Julia afterwards so we can run it again and see. I implemented k-means parallelized with MPI, so familiar with the speed up in general, just not familiar with GPU parallelization specifically. I feel like you need to contact someone. Yeah, I think I'm gonna have to. Which is fine. It is what it is. So I'm just going to go ahead and run this with the same parameters we have for the CPU or for the C++ code over here. But we're not going to be able to get a good... Are we able to... No, I'm not able to clear the memory manually. That's the thing. I can't figure out how to do it. Maybe there's a clearing variable Julia. Maybe I could just use this. Let's see what we have. Has one clear it or remove variable global clear A. Let's see, as of 0.3.19, it's possible to clear global variables. Lily's question here. Julia does not have an analog to MATLAB's clear function. Once a name is defined in Julia session, it is always present. Okay, so that's an issue. If memory usage is your concern, you can always replace objects with ones that have consumed less memory. For example, if A is a gigabyte-sized array that you no longer need, you can free the memory with A equals 0. You can also force this to happen with garbage collection. Wow. Okay. So let's go over here. Let's just type in DA. No, DA is not defined. Oh man, DA. The problem is it's defined on the GPU, but it's not defined in the REPL anymore. Okay, well let's try just doing that clear thing. All right. So let's just try doing that, and let's just do clear of DA, and let's try this. DB and DC. And let's see what happens. Include vector add.jl. Yeah, of course it does. It's not defined. Dang. Yeah, we also tried manually forcing the garbage collector. That also didn't work. So I was like, all right, let's try. Yeah, so I tried gc.gc, which is manually forcing the garbage collector. And so we run this, it runs, but we're still using more memory on the GPU, right? So here, you can clearly see that the GPU memory, this guy right here, is increasing. So it's just, I don't know what the deal is. I don't think the garbage collector understands that these variables are out of scope. I mean, that's totally fair. No, actually, it's not fair. So what's happening, I know exactly what's happening. We're not able to call the CUDA free command. If we could just call the CUDA free command, this would work. I mean, the issue is that you cannot naturally talk to the GPU, right? The discussion between the CPU and GPU always takes time, and it's always difficult to do. So usually this discussion just doesn't happen. And I'd be very surprised, I am very surprised that anyone said that the garbage collector could actually clear GPU variables at all. Because honestly, this discussion doesn't happen. The CPU doesn't just talk to the GPU. And the fact that the garbage collector could somehow grab GPU variables seems very sketchy to me. And I don't know if I'd trust that. So, I mean, I just need to be able to call that CUDA free command, but I just can't. Can you not inline C code in Julia programs though? You can, but then we're cheating, aren't we? Like, because we're using... Okay, well, let me see what happens over here. So comparing, let me take a look at their... What am I looking for? I'm looking for this guy over here. Nope. 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 Okay, well, it's saying that we should use the garbage collector. But let's see if there was a better solution here. Nope, there's no better solution. Great, I'll have a look. Probably not before the next week due to deadlines. Yeah, so this guy's doing the same thing that we were doing, called GPU, gc.gc, break it, main break it. So, I don't know, extern C. Yeah, we can do this. Too many tabs. Well, yeah, I have way too many tabs. I'm sorry about that. What I'm going to do is go ahead and close a lot of these guys. So this is the code I was actually looking for. I'm going to see if they call any CUDA code here. So let me just do Control F CUDA. CUDA native, CUDA blocks, CUDA. No, of course I can't. Reduce warp, inbound sync threads, inbound val. I am not seeing them. Yep, I'm not seeing any of this. That is really unfortunate. Does this work if I just run it? Let me grab this code, raw. Let's do Control A, and let's just open it up over here. So we're just gonna run this, write and quit, and we're gonna open up reduce.jl, all right? Paste it down here so we have the code ready. And we're just gonna go over here, we're just gonna include reduce.jl. Of course. All right, so I don't know how to solve this issue. I think maybe we just call it a day here. We did what we could. It's like the program is supposed to call it, but yeah, it is supposed to clear it by itself, but it's not doing the clearing. So, what are you supposed to do? I mean, like, I don't mind. Like, I don't mind not having a garbage collector. I'm very used to using C++, and you know, manually freeing my own variables is fine to me. I don't mind. That's how all GPU computation works. You always free your own variables. But this isn't allowing me to do that. I mean, I can do the following. I know let me just do vecat.jl, and I guess I'll just say this. And this is a dumb way to do it, but DA equals 0. Okay, I'm redefining what these variables mean. So, is there a garbage collector in GPU, Julia? Is that a good idea? This is the question. I'm not sure. Okay, so that ran. Let's check. It's still using GPU memory. Oh my word. It is still, I don't even know what's happening anymore. I've redefined what DA, DB, and DC mean just to be 0. Like, I'm redefining what the variables mean. It's still using my GPU memory because we can't free the variables on the GPU. Okay. I don't know, man. I'm out. I'm done. I can't figure this one out to save my life. All right, maybe it's not the variables. What do you mean? Call GC in the REPL? Sure. So I'm going to run this. Go over here, and we're going to run Julia. Include vecat.jl. Open up the side guy over here. So here we'll show that it's using some GPU memory. So we have 119. So now after this is done, I will run gc.gc. Now we're still using our GPU memory that we shouldn't be. There's no reason this should be using 120 megabytes at this point in time. We're not touching the GPU. The function is already ran. I mean, it could be that... I don't know. I don't know what it could be. I'm completely at a loss. No, don't get me wrong. When it comes to the Julia GPU code, it is much, much simpler than the C++ code that we're used to. So comparing CUDA to Julia GPU, Julia GPU is way, way simpler. But why is Julia using up all my memory? That's the question I can't figure out. I want to like this. I want to like Julia GPU because if we can get it to work and if it has all the functionality we need, it's perfect. But it's lacking in documentation right now, and it's hard to really figure out what's going on, you know? Because like I don't know what's happening with all the variables. I don't know where they are. I'm having trouble understanding what's on the GPU and what's not on the GPU, and I'm having trouble understanding, like, you know, the difference between my device and my host. It's just difficult. Meanwhile, with CUDA, at the very least, yeah, it's a syntactical mess. But I understand what's happening, you know? And so this is my own personal problem. It's not an issue. Yeah, I think I'll have to contact a dev about that. I think that's true. AC252. I think that's the best I can do. Which means we can't do a quick performance test, I don't think, between Julia and C++. Because honestly, we're not going to be able, I mean, Julia is just keeping all the data on the GPU, right? So if I run it once, I need to run it twice. Okay, so let's try the following. So let me see if I can run this code again. So I did it with 512. Now let's increase this to the size of our C++ code. So that's going to be, length is going to be equal to this here. And then we're going to go down here and we're going to say each of the threads is going to be 100. Okay. And this is going to be something like that. Okay. So now we're going to run at time include vec-add. Actually, I can probably just run main. No, we're going to have to, let me do it this way. So we're going to include vector add.jl without running it. And now we're just going to run at time. Let's do main. Okay, so that took 0.23 seconds. And it says 6.51 garbage collection time, but I don't understand what the garbage collection is doing because it doesn't seem to be doing anything. So now let's do the same thing, and let's just do time, the simple time .a out. This took 0.195. Okay, so we are seeing, even now, we're seeing a performance dip by using Julia, which again is fine. It's kind of what we expected. It's not that big. It's a very small performance dip. So $512. Move this back down to length. And let's change this back to 1. Okay, so we are seeing a bit of a performance hit by using Julia. We're also running into the situation where Julia is, for some reason, just using all our GPU memory because it feels like it. But actually, what happened if I just run main? No, that's interesting. Oh no, it is using more memory. It is definitely using more memory. Can I just look at main? Let's do an at time main. Yeah, okay, it's the same. It's basically the same. Yeah, we have to do multiple benchmarks, I think, to get this working right. But yeah, it's just using more and more memory. So let's do a control D there. So ultimately, we're seeing a bit of a performance dip by using Julia. And don't get me wrong, you know, comparing the at time function in the Julia REPL and using just time based on the executable in the Linux shell, there's some issues here. I probably should have used a high performance clock in the C++ code itself to get the exact performance within the C++ code itself instead of using the using the time command in the Linux shell. Like, there's some issues here with how we just did that test. But as a quick test, I mean, just seeing a performance dip already in Julia is not necessarily a good sign. But also we're running into the issue where Julia is keeping the memories for some reason, or keeping the memory on the GPU and not clearing it for some reason. And I'm not sure how to solve that issue. I have a question. Did anyone else get totally spammed by PM from the Space Devourer guy? Yeah, I got a bunch of messages from him too, but I just assumed it was because I was the person in charge of that, of the Discord, so I just assumed that he just sent me a lot of messages. I wasn't able to really talk to the guy, like, I was too busy. I've been too busy recently, and I haven't been able to do very much. Okay, so what I'm going to do is I'm going to go ahead and commit this to our GitHub repository. So I'm going to add a quick error in here. Julia keeps memory allocated on GPU after running in REPL. So we're going to git add vector add.jl git commit -m. I'm adding vector addition. Let's see. Small error where Julia keeps variables allocated on GPU. Okay, so let's do this. Yeah, I don't know how to fix that. I have no idea. Let's see. If I had a hammer, I'd hammer... Whoa! What's wrong? He's okay. There's nothing wrong with him. He's fine. He just was a little bit too excited. Quite a bit. Yeah. Let's see. I have a larger than average adrenal gland. Okay, well, be careful. And I'm Scottish. You figure it out. Yeah, I guess the guy was fine. He was okay. It wasn't... He's just talking a lot. Are you sure that's, that it's the array variables? It has to be, because the only things that we're sending to the GPU... Let's take a look at it. The only things we're sending to the GPU are DA, DB, and DC. I don't think there's anything else we're sending to the GPU unless... Unless it's len? But len is just an int. That's only going to take up a few, like a kilobyte. No, not even a kilobyte. That's only going to take up like a few bytes, you know? That shouldn't take up too much space. Yeah, that should take up no space. So we shouldn't even be seeing that on the NVIDIA SMI. Also helps if you get the reference to what I said. Yeah, it could be. The difference between talkative and interrupting other conversations with spam. Yeah, I don't know. I didn't see the stuff that was happening yesterday. I only saw some stuff here and there. So, like, I only saw basic stuff. I didn't read the whole chat. I'll take a look at that after that. What about the dev stuff? The dev stuff. Oh, the context stuff. It could be that we're not clearing the context. That could be correct. I don't really understand what this context is because it's not something that we call in the C++ code. So I'm not sure what we're looking at here. Let me see. GDE. Open link. Oh. Okay, fair enough. That URL is a bit too much. That's fine. I don't even understand how they understood what the other was saying. Wait, what? And he said, and this Asian guy were talking to each other. He and this Asian guy were talking to each other. Like, he invited me to server. Oh, yeah. Yeah, I understand. What's happening today, latest backlog? Yeah, I'll take a look at that just before we left. Because even I don't know. I'll take a look at it. Okay, so I think this is it for the day. I understand that we have a bit of an error with like the GPU allocation. There's something wrong. We're allocating memory on the GPU. And for some reason, this allocated memory is not being deallocated, and I can't figure out how to do this. So I'll see if I can contact a developer and go from there. Coding with ethanol. Yeah, I'll hold on. I'll send a screenshot. Yeah, okay. Feel free to. Just take some time. In the meantime, let's see if we want to rate anybody at the end of stream. Let's see who we have online. So, Obother's online. We host Obother a lot. That's perfectly fine. Burgability, I don't remember what he does, but maybe. So if there's someone you want me to host at the end of stream, feel free to let me know. Oh, CosmoQuest. Actually, let's take a look at this CosmoQuest guy. I'm interested because I think he's doing a charity marathon right now. So maybe it's good to do that. Yeah, he's doing Hangout-a-thon. 2018, 40 hours of science for science. How about we host him? I think that's good. If that's okay. He's doing a charity marathon for 40 hours, so I think that's kind of nice to do. Oh no, I forgot today was a GPU stream. Don't worry about it. We ended up just failing miserably at implementing a Julia GPU kernel, so it was okay. Yeah, let's do CosmoQuest. Let's do that. Okay guys, so that's it for the day. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, which is tomorrow. It's going to be a bit of a longer day where we are going to be working on, what am I going to say? We are going to be working on the algorithm archive for a bit of a longer stream. I like Obother, but this guy seems cool too. Yeah, we'll take a look at him. It's fine. I rate Obother a lot. So let's move on. Let's try to rate a whole bunch of different people. So tomorrow, again, I'll be live for a bit longer doing algorithm archive stuff. There's a lot of discussion to have there, so I'm really hoping a lot of people come on because there's just a bunch of stuff that we need to just hammer out and start working on. And hopefully we can get the algorithm archive up, ready to go, fixed with a whole bunch of things. It's just a lot of stuff to do, so I'm pretty excited for tomorrow. And I will see you then. Thanks, guys, and have a wonderful time. Bye.